Chapter 7, Force and Motion. Gravitation is the force of attraction between any two heavenly bodies in the universe. This force is called gravitational force. Its formula is F equals G times M1 times M2, D2, where G is the gravitational constant, M1 and M2 are the masses, and D is the distance between their centers. Its unit is Newton. Now, this gravitational force depends on two main factors: product of the masses involved, distance between their centers. Let's go through Newton's universal law of gravitation. It states that the force of attraction between two bodies is directly proportional to the product of their masses and inversely proportional to the square of the distance between them. So combining these, we get F equals G times M1 times M2 slash D2. This law is called universal because it applies to all objects with mass in the universe, be it apples, planets, or galaxies. Now, let's discuss what happens when we change the distance. Heavy if the distance is doubled. Then the force becomes 1/4. Heavy if the distance is halved. Then the force becomes 4 times greater. Heavy if one mass is tripled and distance is halved. Then the force becomes 12 times greater. Now about gravitational constant, G. It is defined as the force of attraction between two unit masses kept 1 meter apart. Its value is 6.67 times 10 nm2/kg2. If someone asks you what it means, you say, it means that the gravitational force between two 1 kg masses kept 1 meter apart is 6.67 times 10 Newton. Now, let's come to gravity. It is the force by which the Earth attracts any object towards its center. Its effects are: we can walk, run, and work. Buildings and bridges stand still. Water flows downhill. Atmosphere stays around Earth. And anything thrown up falls down. What is acceleration due to gravity, G? It is the acceleration produced in a freely falling body under gravity. On Earth, its average value is 9.8 ms2. At poles, 9.83 ms2. At equator, 9.78 ms2. On the Moon, 1.67 ms2. On Jupiter, 25 ms2. That means every second a falling object increases its velocity by 9.8 ms on Earth. Does G depend on mass? No, Galileo proved this. When a feather and a coin are dropped in a vacuum, they fall at the same time. So, G is independent of mass. Now prove that G proportional to 1r2. Let the force acting on a body on Earth be F equals G times M/r2. From Newton's second law. F equals M times G. So equating M times G equals G times M/r2. Right arrow G equals G times M/r2. This shows G is inversely proportional to the square of the radius of the planet. Now, a quick comparison between mass weight, amount of matter force by Earth, measured in kg, measured in Newton. Constant everywhere changes from place to place. Measured with beam balance, measured with spring balance. Let's define free fall. It's when an object falls under gravity without resistance. Weightlessness. When a body seems to have no weight, this happens during free fall, in outer space, at the null point, at the center of the Earth. How does a parachutist land safely? When he jumps, velocity increases. This increases the upward air resistance. Eventually, the upward air force balances the downward gravitational force. So the parachute falls slowly and safely. Now some quick questions. Geocentric theory, right arrow Earth is center. Heliocentric theory, right arrow Sun is center, proved by Galileo. Who measured G? Right arrow Henry Cavendish. What affects gravity? Right arrow mass and radius of planet. Condition when G equals G. When unit masses are kept 1 meter apart. Important relations. W equals G times M slash R2. At greater altitude or in mines, radius or effective mass changes, so weight changes too. Heavy more G at poles right arrow, because smaller radius. Heavy less G at equator right arrow larger radius. Heavy on moon, weight is 1/6 right arrow due to low gravity. Heavy in vacuum, feather and coin fall together. Heavy we jump 6 times higher on moon. Heavy dangerous to jump from height right arrow, due to increasing velocity. Heavy tides occur in ocean, not in lakes right arrow ocean has more mass. Heavy moon causes more tides than sun right arrow moon is closer. Heavy earth has atmosphere, moon doesn't right arrow earth's gravity is higher. Let's compare. Gravity gravitation. Force by earth force between any two masses. Not universal. Vector scalar. GJ. Acceleration constant. Vector scalar. M/S2 and M2/kg2. And finally, weight varies, mass remains constant. Object falls faster at poles than at equator. Value of G is 0 in outer space, null point and Earth's center.